These are the prep packet videos for Unit 3, Chapter 8.5, and we'll be looking at objective number 1. In this objective, we are looking at word problems. In fact, in this entire section we are. And before we get started, I just wanted to go over a couple of things regarding word problems. First of all, I want to make sure you remember the rules. Make sure that you read the problem carefully. And once you've read it, I want you to read it again. A really important thing to think about is what kind of a problem is it? If you can identify the different types of word problems, it's going to be a lot easier for you to decide what tool you need to solve them. So you might want to look at this and think, am I comparing amounts or looking for a missing component, a missing piece of data? In this case, that's often a proportion problem, percentage problems, and ratio problems. Sometimes the problem involves rate and time. That can be a distance problem, and it can also be a work problem or a completion problem. Those problems are often asking you how far, when will it be finished, when will it be full. In this same family, for the simple reason that distance equals rate times time, we have rate problems. Rate problems usually ask you how fast something is going. So how fast tells me I'm working in that family most of the time. And as you do more of these, you'll get a sense for what type of problem it is. I call these job problems, and they'll be covered in their own section farther down. But a job problem, again, is when will you be finished? And a lot of times these involve combining rates. So you work this fast and I work that fast. Or John eats this quickly and Sam eats that quickly. You're combining efforts. So once you've decided what kind of a problem it is, you have to choose the variable. And this means basically that you have to come to what I call the heart of the data. And this is the variable that everything else relates to. So, for instance, if you're told that Batman is 28 years older than Catwoman, and their ages add up to 70, I'm going to come through this and I'm going to look for the heart variable. And usually, a lot of times, of course not always, but the word than often tells me what the heart variable is. Catwoman is the heart variable because we start with her age, C, and then we add 28 to it to get Batman's age. So Catwoman is C. Oops, I was going to write Catman and Batwoman. A whole new series is born. Catwoman is C and Batman is B. And it says if I add their ages together, I'll have 70. So here, C plus B equals 70. And we're going to use C is Catwoman, and that's the heart variable. Because if I take that and add 28, I can have Batman. So here I've just set it up as C plus 28 equals 70. Combine like terms, 2C plus 28. Isolate the variable, and eventually I will discover that Catwoman is 21, and since 21 plus 28 is 49, Batman is 49. So let's take a look a little farther. We're going to start now and look at some problems with proportions, applications with proportions, and these are pretty common and you've seen them before, but just to remind you, with proportions, you usually start out with one relationship and compare it to another relationship, which usually has a missing component. So in this case, I'm looking at the relationship between hand and arm is the same as foot and what? Leg. I had the original relationship, and now they want me to look at a new relationship. Same idea, different part of the body. So that's basically sort of a part to whole situation. You can also compare part to part and then whole to whole. So hand is to foot as, what am I missing? I've got leg down here, so I've got foot and leg on the bottom, hand and arm on the top. A very, very important thing to keep in mind with this kind of a problem is that you can't mix things up. If I'm comparing cats to dogs, and I have 7 cats and I have 14 dogs, I have to make sure that I keep these in the same order with my new data. So if they're telling me I started with 7 cats and 14 dogs, and the new relationship is 14 cats and I don't know how many dogs, I better make sure that all my cats are in a line and all my dogs are in a line. Or your ducks in a row, if that works for you. So once you set up your primary relationship, which in this case, for instance, is 3 to 10, and I know that these look like fractions, and these are actually, in this case, they're ratios, which have more to do with relationships. A fraction is a type of ratio, but you'll see different kinds of them. So here, the first thing I was given was the fact that there's a relationship between 3 and 10. The same relationship exists between 36 and some other number. They will have the same ratio. And what you'll do is using cross multiplication, and remember I can only multiply or divide over the equal sign. So I have 3 times x is 3x, and 36 times 10 is 360. I have set up my primary relationship, and I'm going to use cross multiplication to solve for the variable. So 3x equals 360, divide both sides by 3, and I get x equals 120. And if I sort of look at this, I can tell that I bumped this up by 12, I should bump this up by 12, and 12 times 10 is 360. So my answer makes sense. Go ahead and copy this. If you have any questions, make sure you review it. Stop and copy right now, though, and I will meet you on the next slide. So here's a proportion that we're going to set up. They are telling us that 4 pounds of coffee costs $27.80. That's my initial relationship, 4 pounds, $27.80. And usually we talk about coffee in how much per pound. And when you see the word per, remember that's something per something. That line, that dividing line between the fractions, that's the same as per. Okay, so this initial relationship is in pound. Usually we talk about cost per quantity. So cost per quantity, and that is dollars. What is going on with that? Sorry. That's dollars per pound. And we had 27.80 over in relation to 4 pounds. And now we have our original relationship set up, and now they want us to take a look at a new one. And we'll do a new relationship, and they're telling us that we have 6 pounds, and we don't know how much it will cost. So our unknown is x for cost, and we have 6 down here. And here we're just going to cross multiply, and I have 2780 times 6 equals 4x. If I do all the math with the magic of television, I will have 16680 equals 4x, and 4170 will equal x. So that tells me that in my new relationship, that should be 4170. And that makes sense because 4, 2, 6, 4, it's within a reasonable amount. So go ahead and stop and copy, and I'll meet you on the next one. This one is a ratio problem, and we are looking at students who went on a spring break and students who did not or stayed home. So we're going to compare the students who went to the students who stayed home. The problem tells us that the ratio of the students who went to the students who stayed is 3 to 1. Now, here again, I'm going to look for my heart variable. I know this is a proportion problem, so I'm going to look for my heart variable. And the number of guys who took a trip was 24 more than, and I know this is not guaranteed, but it sure is a good place to start. I'm going to use the guys who didn't or the guys who stayed as my base variable, my heart variable. So S. And they're telling me the number of guys who went is 24 more than the number who stayed. So stayed plus 24. And that number equals the original relationship, which is 3 to 1. So we can again use cross multiplication to solve for x. And again, I can use cross multiplication because I'm working across an equal sign. So this tells me that 3s equals s plus 24. And we can subtract that s and that s. So we'll have 2s equals 24. S equals, divide both sides by 2. S equals 12. And let's check it. Is it true that 12 plus 24 over 12 is the same as 3 to 1? Well, let's take a look. That's 36, and that's 12, and 12 goes into 36 3 times, so it does check. So again, go ahead and copy, and that's it for this video. Thanks a lot.